Welcome to Two Projects. In this video, we are going to explain the project Real-Time Attendance Monitoring System using Machine Learning and Blockchain. Introduction. Traditional methods of tracking attendance such as manual recording or RFID cards are outdated and inefficient. The project aims to revolutionize this process by introducing a modern and efficient method leveraging technology. Traditional methods suffer from various drawbacks, including inefficiency, inaccuracies, and susceptibility to fraudulent practices like proxy attendance. These challenges highlight the need for a more robust and secure solution. So, to overcome the limitations of traditional methods, the project proposes the integration of OpenCV technology and machine learning for facial recognition. This approach ensures accurate identification of individuals present in a class, improving the reliability of attendance tracking. And blockchain technology is introduced to address security and transparency concerns. Blockchain is like a digital ledger that records transactions securely and transparently. Instead of having all the data in one place, blockchain stores records as blocks of data, each with a unique code called a hash. These blocks are distributed across multiple computers or nodes, making it much harder for anyone to tamper with the data or compromise the entire system. And blockchain offers several advantages. First, it is decentralized, meaning the data isn't stored in one vulnerable location. Second, it enhances security because the data is stored in encrypted format that is very difficult to alter or hack. Third, it promotes transparency as all transactions are recorded and visible to authorized users. Fourth, it ensures data immutability, meaning once something is recorded in the blockchain, it can't be easily changed. Finally, it is resilient to failures because even if some nodes go down, others continue to maintain the data. And Ethereum's blockchain platform is utilized along with smart contracts to execute attendance related transactions. Smart contracts act as digital supervisors, enhancing the efficiency and reliability of attendance tracking. This ensures that transactions are executed securely and transparently without the need for intermediaries. Objective of the project. So, as I mentioned earlier, the primary objective of the project is to develop a system that can accurately capture attendance data in real time. This addresses the inefficiencies and inaccuracies associated with traditional manual methods of attendance tracking, which often rely on error prone processes such as taking roll call or using physical attendance sheets. And the project aims to incorporate OpenCV, a popular open source computer vision library for precise facial detection. Additionally, machine learning algorithms such as support vector machines, k-nearest neighbors, and convolutional neural networks will be utilized to enhance the reliability of identifying individuals present in the classroom. By leveraging these technologies, the system can accurately recognize faces even in varying lighting conditions or different facial expressions. Another key objective is to utilize blockchain technology for securely storing attendance records. By leveraging a decentralized ledger, the system ensures immutability, transparency, and protection against tampering or unauthorized access. And the project aims to design a user friendly interface to streamline attendance tracking procedures. This includes functionalities such as allowing users to easily check in and check out, view their attendance records, and receive notifications. Smart contracts will be employed to streamline attendance tracking processes, reducing manual effort and improving overall system performance. Smart contracts enable the execution of predefined rules and conditions, ensuring transparency and efficiency in managing attendance data. Requirements needed to execute this project are software requirements, Python IDE of 3.7.0 version, Node.js, Visual Studio Community version, Ganache, and MetaMask Chrome extension. Backend languages used are Python, JavaScript, and Solidity. Framework used is Flask. Frontend languages used are HTML, CSS, JS, and Bootstrap 4. Hardware requirements needed are processor of i5 and above, RAM of 8 GB and above, and ROM of 20 GB and above. So to execute this project, we have designed few modules. The first module is admin registration. So this module facilitates the registration of administrators, enabling them to manage user accounts and access attendance data securely. Administrators provide basic information and credentials, ensuring authentication and authorization for system access. The next module is admin login. So, admin login grants registered administrators access to system functionalities after successful authentication. This module employs robust authentication mechanisms to verify administrator identities, safeguarding sensitive features from unauthorized access. The next module is Add New User. Here, administrators can add new users by providing their name, ID, and facial data. This module ensures an updated database of individuals eligible for attendance tracking, with facial data captured and securely stored for recognition purposes. And the next one is Take Attendance. So, using facial recognition technology, this module allows administrators to conduct attendance sessions seamlessly. Live images of individuals are captured, compared against stored facial data, and attendance is recorded in real time, streamlining the process and minimizing errors. Blockchain integration. So, blockchain technology is employed to securely store attendance records on a decentralized ledger. Each attendance record is cryptographically linked to the previous one, ensuring immutability and transparency. This ensures that attendance data cannot be tampered with or altered, providing a reliable and transparent record of attendance. Smart contracts are utilized to streamline attendance tracking procedures. These contracts define the conditions for attendance related transactions such as recording attendance, updating records, and generating reports. By leveraging blockchain based smart contracts, the system ensures transparent and efficient execution of attendance related tasks without the need for intermediaries. And by utilizing blockchain for storing attendance records, the project enhances security and transparency. The decentralized nature of blockchain ensures that attendance data is distributed across multiple nodes, reducing the risk of a single point of failure or unauthorized access. Additionally, the transparent nature of blockchain allows stakeholders to verify the integrity of attendance records, fostering trust and accountability in the system. And we have used Ganache in this project. So, Ganache is a user friendly interface for monitoring Ethereum blockchain activities. It simplifies tracking of accounts, transactions, and smart contracts, making it accessible even for users without in depth blockchain expertise. Ganache offers detailed transaction information, including sender, receiver amounts, gas usage, and success status, aiding debugging and ensuring transaction accuracy. It also tracks smart contract deployments, confirming correct deployment and functionality. This transparency simplifies monitoring and verification processes. And Ganache lets us dive into the details of each block on the Ethereum blockchain. We can find out when a particular block was added, what transactions took place within it, and how much computing power, that is, gas, was used. Ganache also enables data retrieval from stored blocks, allowing developers to access and analyze specific block information. And we have also used MetaMask in this project. So, MetaMask is both an Ethereum wallet and a browser extension. It simplifies cryptocurrency management and provides direct access to dApps, making interactions with blockchain applications easier. And in this project, MetaMask ensures secure Ethereum transactions, promoting transparency by showing the deduction of ETH as fees. This transparency maintains accuracy and ensures confident, reliable financial interactions within the system. Now we'll understand about the algorithms used as extension to the project. So first we'll understand about OpenCV. It is a powerful open source library designed for computer vision and image processing tasks. It provides a wide range of functions and algorithms for tasks such as object detection, image segmentation, and feature extraction. In this project, OpenCV is utilized for its robust capabilities in processing facial images, extracting relevant features, and preparing them as input for recognition models like SVM, KNN, and CNN. Its versatility and efficiency make it an ideal choice for handling complex image processing tasks, ensuring accurate and reliable face recognition in real world scenarios. And the first algorithm used is support vector machine. So it is a powerful supervised learning algorithm used for classification tasks, including facial recognition. SVM works by finding the optimal hyperplane that best separates different classes of data points in a high dimensional space. It maximizes the margin between classes effectively, reducing the risk of misclassification and improving generalization performance. In this project, SVM is suitable for facial recognition because it can efficiently handle high dimensional feature vectors extracted from facial images, making it effective in distinguishing between different individuals based on facial characteristics. The next algorithm built is k-nearest neighbors, that is KNN. So KNN is a straightforward algorithm for classification including face recognition. It works by finding the closest data points, that is faces, in the feature space and assigns the input face to the class that is most common among its nearest neighbors. KNN is suitable for this project due to its simplicity, computational efficiency, and robustness to noise, making it effective for small to medium sized datasets and varying facial expressions and lighting conditions. And the next algorithm built is convolutional neural network, that is CNN. So CNNs are specialized deep learning models ideal for processing grid-like data such as images. They utilize layers of convolutional filters to extract hierarchical features, allowing them to effectively capture patterns and spatial relationships within images. Due to their ability to learn complex representations directly from raw pixel data, CNNs are well suited for tasks like facial recognition, making them a perfect choice for this project. Now we'll see the comparison graphs of the extension algorithms. So this is the bar graph comparing accuracy scores of different algorithms. In this graph on x-axis, I have algorithm names and on y-axis I have accuracy scores. Accuracy measures the overall correctness of predictions, showing the percentage of correctly classified instances. This is precision scores comparison graph. In this graph on x-axis, I have algorithm names and on y-axis I have precision scores. Precision measures the accuracy of positive predictions, indicating how many predicted positives were actually correct. This is recall scores comparison graph. In this graph on x-axis, I have algorithm names and on y-axis I have recall scores. Recall measures the ability to identify all relevant instances, showing how many actual positives were correctly predicted. And this is F1 scores comparison graph. In this graph on x-axis, I have algorithm names and on y-axis, I have F1 scores. F1 score combines precision and recall into a single metric, balancing accuracy and completeness in predictions. So the algorithm which is best performing in all the performance metrics will be used for predictions. And we can see SVM is doing well in all the performance metrics. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is attendance folder where the attendance of the students will be stored. This is empty right now. This is contracts folder in which I have Solidity files. They handle data structures, functions, and events with modifiers for validation. This is static folder. It consists of files related to CSS, JavaScript, and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. And this is model file which contains algorithm information. This file will be loaded into the project code during runtime to utilize the trained models. And this is notebook Jupyter source file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is run.bat file to start the attendance management system. So before that, first we need to host the server. For that, open the Ganache. So we can see the server has been hosted. Now we'll get back to the code folder. Now double click on run.bat file to start attendance management system. Instead of executing the project through command line interface, we have created these Windows bat files to execute the project. So the Flask framework will host the application locally at the default address, local host, and port unless configured differently. Now copy the local link provided by the framework and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a login link, click on it. So if you are already a member, we can give our credentials and click on login button to sign in. If you are new to the system, we have to sign up first. Click on this link. Here we have to fill in these details and click on register button to sign up. Username would be admin, name would be admin, give the email ID, give the contact number and the password. Now click on register button. So the registration process is completed. Now we'll sign in. Click on sign in link. We have to give our credentials here and click on login. So it has redirected us to the attendance page. So all these registration details will be stored in blockchain in a form of block. We can see that in Ganache. So here we can see a block has been created in which all these registration details will be stored. So we can retrieve the data from here. Minimize this. Now click on the MetaMask extension. So we can see I have a balance of 99.9843 ETH in my MetaMask wallet, which represents the deducted amount after recent transactions. So in the context of a blockchain, transactions refer to the actions or operations that are recorded on the blockchain ledger. Here, administrators can enroll new users or students into the system by providing their username and ID. Additionally, facial recognition is required for identification purposes. So username would be Shreya, user ID is 50. Now click on add new user link. So present your face here for the system to learn its features from all the angles and expressions. So the system will stop learning after acquiring 50 features automatically. Now we'll take the attendance, click on take attendance link. So here we have to show our face again for recognition. Once a face is detected, the system will draw a bounding box around our face and it will show our name with ID number. And the admin can mark attendance by clicking the A button. So we can see the attendance has been marked. We can see the list of student details who have been marked as present here. We can see serial number, name, ID and time. So similarly, the admin can create any number of new users and conduct attendance using face recognition. So the conclusion here is the project has successfully introduced a modern and efficient method for attendance tracking, addressing the limitations of traditional manual methods through the integration of advanced technologies. By leveraging facial recognition technology and blockchain based smart contracts, the system has significantly improved the accuracy and efficiency of attendance tracking processes, reducing the risk of errors and fraudulent activities. The utilization of blockchain ensures transparent and secure storage of attendance records, enhancing data integrity and protecting against unauthorized access or tampering. And the utilization of OpenCV for image processing, along with extensions like support vector machines, k nearest neighbors, and convolutional neural networks models, further enhances the project's capabilities. Through extensive testing, SVM has emerged as the top performing model, demonstrating superior accuracy and reliability in facial recognition tasks. Consequently, SVM's deployment in Flask, a user-friendly web framework, underscores its effectiveness in streamlining attendance tracking procedures and ensuring optimal system performance. So the system incorporates a user-friendly interface, allowing administrators to easily manage user accounts, conduct attendance sessions, and access attendance data, thereby streamlining administrative tasks. Moving forward, the project opens up possibilities for further enhancements and innovations in attendance tracking systems. Continuous monitoring and feedback will drive improvements, ensuring the system remains up to date and adaptable to evolving needs and technologies.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.